My name is Dan Garfield. I'm a co-founder and chief open source officer at CodeFresh, and really I'm also a Argo maintainer, and I do a lot more of the kind of community organizational work stuff. My commits are the weakest of all the maintainers, but excited to be here and to be introducing our speaker, who's kind of a legend, frankly. Chris, I always call you Chris. Is that okay? But I've just noticed that it's always written Christopher, so maybe I've been saying it wrong the whole time.
I do go by Christopher at work, although when I joined, there was Chris Elaine already on staff. We were like, this is gonna be confusing. So I just went ahead and used Christopher at work. A lot of folks in my call me Christopher outside of work too. So I respond to both, and I'm not particular about it.
Got it. Okay. Well, we'll say Christopher. So Christopher is lead solutions architect at principal enterprise architect at Chick-fil-A. And Chick-fil-A is sort of legendary for being one of the first, really, that I had seen retailers to go edge Kubernetes full on. And now we've seen edge Kubernetes clusters in additional restaurants, additional retail. We've seen them in container ships. So a lot of the ocean faring vessels, they're using Kubernetes at edge. And then, of course, now we know that F-18s, F-16s are using Kubernetes to run their services. So talk about running at the edge. And in my mind, Chick-fil-A is really one of the pioneers of doing that, and was very early to realize the value of doing edge clusters, doing Kubernetes, and of course, doing Argo CD and Argo rollouts and some of these other things. And before you kind of kick off, Christopher, sorry, I had a chance to meet you when we were at GitOps Con in LA. And of course, we do have GitOps Con EU for people that are going to be attending KubeCon EU in Valencia, Spain, or just attending virtually. Check out GitOps Con. Going to have a ton of great talks on that. Of course, we had Argo Con 21. So if people haven't seen that, go back and watch those talks because they're phenomenal. We hope to do a lot more of these meetups, and then we'll do different local, events and stuff at these different places. But Christopher, at the time when I first saw you talk, you had named your platform the Chick-fil-A application platform, or CAP.
Yes.
And internally, we had a huge laugh about this because CodeFresh launched a CodeFresh platform. This is like the enterprise version of Argo is what we're selling. And we actually called it internally for a long time CodeFresh Argo platform. So I was like, they're already using CAP. Oh, wait. And then I was like, well, they're probably not going to commercialize it. We'll probably be okay. So with that kind of funny, observation, I suppose, I'll get out of the way and let you talk. And then I'll be monitoring the chat and monitoring the Q&A. And I think we'll probably have some time for Q&A at the end, and we can invite people to do that. So as you have comments, put them in the chat. Don't forget to follow on Twitter, the Argo Project on Twitter, CodeFresh on Twitter. I'd love it if you follow me on Twitter. I'm at Today Was Awesome. And with that, Christopher, it's all yours.
Yeah, thank you so much. Let me share my screen here. There we go. Hopefully you guys can all see that okay. And yeah, no, actually internally, the first iteration of CAP was actually called KCP. And we had to change it because that is a very common alias for kubectl copy. So we did some internal switch around of that too. But no, I would not want the code for CAP released, having written a lot of it's not for external consumption. But good evening, everyone. My name is Christopher Lane. As Dan said, I'm a member of the enterprise architecture team at Chick-fil-A. I work primarily with customer technology solutions, CTS. So if you hear me slip into a little jargon, that's what I'm referring to. CTS is responsible for building and maintaining all customer-facing applications at Chick-fil-A. That has historically been the Chick-fil-A app, our mobile app, and .com. It's growing to include some other customer-facing services and applications as those expand. Today, I'm going to be talking about GitOps in the real world based on our experiences managing Chick-fil-A's customer-facing digital properties. So first, a little bit about who we are. Hopefully, most of you guys, folks know who Chick-fil-A is, but just in case, we are a privately owned quick service restaurant based in Atlanta, Georgia. We started with a very simple idea from our founder, Truett Cathy, to fill the needs of his customers, the Chick-fil-A chicken sandwich. We have grown from that idea to more than 2,400 restaurants and Kubernetes clusters, mostly in the US, though we have recently opened locations in Canada and Puerto Rico just this past week. Our per restaurant scale is significant. We have by far the highest per restaurant sales in the QSR industry. And currently a very significant portion of our sales are flowing through our digital channels. So that's mostly driven by our mobile app and .com. And we've seen significant growth in those channels since March of 2020. And we all know that that's when the impacts of COVID-19 started in North America. And our traffic patterns have changed since then. Sorry, my kids are in the background. Our digital properties are powered by our digital experience engine, DXE. So sorry if I drop in a little jargon there too, but it's the digital experience engine. We started migrating DXE to Kubernetes-based platform in the summer of 2018. We completed that journey in the summer of 2021, so about 3-year journey. Before that, we actually had started our Kubernetes journey as a company by deploying clusters to the edge, the restaurant. So we now have a cluster in every single restaurant. So we actually started the edge a little bit before we started our cloud journey. I'm going to focus on DXE in this presentation. Happy to answer questions about either the DXE cloud-based services or the edge-based services. So first, let's take a look at what DXE scale and traffic looks like. So this is the number of requests through DXE on a typical day last fall. There's nothing special about this day. We just picked one. The pattern probably isn't terribly surprising to anyone, especially for a restaurant. The requests ramp up during breakfast, spike at the peak of the lunch rush, and finally hit another smaller peak during dinner. If we're running a national or a set of regional promotions, these numbers can easily double. But on average, we hit about 300,000 requests per minute at lunch, average about 120,000 during the day, and service more than 150 million requests total. The DXE team behind these services is composed of a bunch of developers, including both internal staff and external contractors. Together, this team pushes thousands of commits and opens hundreds of PRs every single week. I also really love this graph because it looks like we don't have any issues. We do. We have issues, but they're largely tracked outside of GitHub, so they're not accurately represented here. But our application platform is entirely GitOps based. So our developers need to traverse our process to get their code deployed every single day. We have no formal blackout times during the day when teams can't push or deploy. So this process has to flow smoothly. Next, let's take a look at the DXE architecture. So this is the high-level DXE architecture. It's relatively straightforward. Requests from the mobile app and .com are routed to services running in EKS. That's Amazon's Elastic Kubernetes service. We currently have clusters in multiple regions. This is largely for failover. We don't typically run services as primary in separate regions simultaneously. The setup is the same in all regions, at least as much as we can make them. And we regularly try to route traffic entirely to different regions to ensure we don't have any sneaky hidden dependencies there. That's primarily sneaky hidden dependencies in US East 1. Our services are mostly Java Spring Boot applications with some Go and Python apps mixed in. The apps are backed by global DynamoDB tables. The data in Dynamo is streamed to a set of Aurora databases for real-time analytics. The app data from Dynamo and the analytics data from RDS are streamed to an S3 data lake. The digital born orders, so the orders that begin life on a digital property, are combined with the traditional orders coming from the point of sale terminals in the restaurants, and so that our analytics team have a near real-time picture of transactions during the day. Let's zoom in on the EKS part of this. And as Dan mentioned, we have a very clever name for this platform internally. It's called CAP, Chick-fil-A's application platform, maybe a little too on the nose. But this is how we think of CAP as a distribution of Kubernetes. As shown above, CAP is a series of layers, the K8s being the base, on top of that a sys, and then core, and then the app layer. This certainly isn't a complete list of components. The slide would be largely unreadable. We added them all, but hopefully this gives an understanding of the kind of components that are included in CAP. These layers are meant to be composable, with teams free to add or remove components to taste. CAP, however, does have opinionated defaults, so folks don't have to worry about choosing components unless they want to. So as I mentioned, the base layer is EKS. On top of that sits the sys layer. That includes things like external secrets for integrating with AWS Secret Manager, external DNS for managing Route 53, the BioRocket operator for updating and patching our node groups. So the only node groups we have are cluster right now are BioRocket nodes. The autoscaler, obviously, for scaling the cluster. The AWS load balancer for managing the front door, essentially, and then just a variety of other cluster and circuit service metric providers. On top of that is the core layer. This is the largest layer of CAP and where a team might switch out a component or two. So we started originally before we found Argo CD with an in-house GitOps operator. So that was a changeover some folks made early on, but Argo CD is the heart of CAP at the moment. It watches obviously what we call the Atlas, which is just the internal name we have for the Git repo where we declare the entire state of the cluster. So Argo's watching that repo and applying any changes to it to make sure the state of the cluster always matches the state we've declared. And Git CloudWatch adapter for scaling services based on CloudWatch metrics. We got to update that one soon. That one's deprecated. FluentD for sending logs to various log syncs. OPA for creating and maintaining admission controllers. Prometheus operator for maintaining the Prometheus and Grafana stack, Thanos for long-term storage, Prometheus matrix and S3, and just a variety of other tooling, including operators for managing advanced deployment patterns. So we're actually using Argo CD rollouts to do canary deployments now in production, for tracking costs, for managing CI/CD jobs. So we use GitHub Actions internally. We migrated from Jenkins to GitHub Actions last year-ish. And so we have some self-hosted runners that are running in the cluster, and then some mocking frameworks for doing unit tests and integration tests and those kinds of things. And then sitting on top of CAP is the most interesting layer. This is where developers work. Our teams obviously rely on the components of CAP, but we try to draw a clear line of responsibility. Obviously, we all know it's a little blurry between these lines, particularly when something is going wrong. But CAP is responsible for K8, sys, and core, and then the developers are responsible for the app layer. So what does the deployment process look like? How do people deploy something to CAP? So at a high level, this is what it looks like. This is the overview of the entire dev deployment process. So this is what happens every single time somebody pushes a commit to the mainline development branch. And we can just walk through this step by step here. So the process is started kind of as always by a developer pushing a commit to the mainline branch. That triggers the build workflow in GitHub Actions. The app container is built. All tests are run, and we'll assume they pass. Obviously, if they don't, this process exits, and the image is pushed to Artifactory. Next, the workflow pulls the base manifests from base manifests for that from our customized base feeder repos. These repos are probably worth a dedicated talk all on their own, and hopefully we'll have a blog post that explains a little bit more about them in detail shortly. But at a high level, they contain our default manifests for various application types. So think Java API, Go API, Python API, or React app. And the default manifests are merged. So those default manifests are merged with any application-specific overlays found in the application repo using customize. And so what we like to think of is this gives developers sort of an easy button they can press to get their application deployed to K8 with sort of minimum knowledge of how to write a Kubernetes deployment and what they need there. Developers are free to patch anything in the base manifest, but the default should work for most applications. We spent a lot of time working on the base manifest and suffered through some degraded performances and outright outages, getting those base manifests right. But hopefully it provides the teams with an easy way to deploy their applications without feeling overwhelmed by having to write and maintain a potentially gigantic pile of YAML. And so as they learn more about Kubernetes and would like to modify the behavior of their application, they can learn to patch what they need. And so their knowledge grows with their need there. So that was kind of the idea behind the theater repos and allowing folks to patch in any changes in the application repo. So next up, Argo, like I said, is watching for changes to a specific deploy branch of the Atlas. In this case, we'll say it's dev US East 1. And once those changes are pushed by GitHub Actions into the Atlas, Argo will pull down and apply those changes to the cluster. So it'll pull the image that was built and pushed to Artifactory over, and then update the cluster. So that's dev. What does higher level environments look like? So we'll just say that there's a QA environment, and we want to push that change now to QA. So it's similar overall, but starts a little bit different. It begins with a merge from the main line into a dedicated deployment branch. So these are long-lived deploy branches. In this case, we'll say it's deploy/QA/US East 1. It could be a little bit different depending on the team's naming conventions, but it'll be something similar to that. And then that kicks off what it looks like to be a very similar workflow from dev. Obviously, we don't need to rebuild the container or anything like that, but we do repull any overlays that are specific to that environment and region. So there could be some changes that need to be made between dev and QA or between different regions. So we'll pull those, rebuild the complete manifest, and then push that to, say, the QA US East launch branch of the Atlas. Argo, again, is watching that as well. And we'll see those changes and then deploy the new version to the correct cluster. So, okay, so that was a lot of stuff. It took us a long time to get to this process. And it's working, but it isn't perfect. And so what are the pain points that we've noticed? So currently, this process is implemented almost entirely using shell scripts and GitHub Actions. We've thrown almost all the UI UX out the window in the name of GitOps. We feel good about that trade-off, but it's one we shouldn't have to make. We want both GitOps and a nice UI UX. And we would like to partner with folks in the community to help solve this kind of problem. So, for example, we'd love for Autocomplete, very strong autocomplete when validating YAML and JSON and TOML with prompts for the available fields and options, just like my ID does currently for the programming languages. And AWS, and Azure, and GCP, and Argo have all largely solved this with a guided UX for building and deploying applications. But we can't really leverage any of that right now with our GitOps platform. So, for example, this is from Argo CD. This is how you can create an application from the UI directly. And most of the issues we raised before are addressed here. So the available options are listed or have drop downs. There's referable targets are provided. There's even hints, but this doesn't work with our GitOps process. We need to dump this into the Atlas. If you created this here, we basically don't allow developers to use this UI, but if they did create one this way, it wouldn't be creatable, or it wouldn't be recreatable or auditable because it wouldn't be in our Git. atlas. And so we're not really able to use that. And then the GitOps version of it looks like this, right? What other fields and values are valid for us to add? What are valid values for fields we do know? And sources of this information, you know, they're sort of varied. They come from internal and external documentation, web searches. People are copying and pasting from existing projects, and you know, looking up other valid sources and copying and pasting. But it's largely trial and error, right? Folks are guessing at the value, pushing that, and then fixing what breaks. But we have, you know, we have succeeded in our creating a GitOps process. So we have an audit, and we can recreate it. Everything's stored and versioned in Git. So we've succeeded with that. But what we see as the proposed solution, you know, obviously one option would be to abandon GitOps. We're not going to do that. We love all the benefits we get from the GitOps model and the ability for every deployment process just look like a regular Git process. But what we want is UI editing with Git as the data store. So if you recall, there was an edit as YAML button on this Argo CD. So that, I think, is the key. That's what we view as the key here. And then ID plugins for validating these sorts of things. And we very strongly feel like these solutions, we can work with the community to get these solutions up and running. We would very much not like to design them in-house. So we're basically saying, but yeah, that's sort of what I was going to talk about today. We always like to finish with a quote from Truett. No goals too high if you climb with care and confidence. This was a quote that led the DXE team quite a bit. We named one of our conference rooms Climb with Care, and it served us well on our KH journey. I do have a blog post coming out about this shortly, and we should add some other things, particularly about the customized feeder repos and a few other things of that nature. But that's it for us. Thank you so much.
Awesome. Thank you, Christopher. That was really informative and straight to the point and awesome. So folks that are on live, if you want to add some questions or Q&A, or even just throw some kudos in the chats, we love to see it. Something I was kind of curious about just listening to this, and we didn't talk too much about it, but beforehand, you were telling me that each store essentially has a 3-node cluster and they're just Intel Nukes, right?
Yeah. There's so every single store has a cluster. We send 3 Intel Nukes, like you said, and there's like a 1-page diagram of how to start it up. And so you plug it in, they essentially network together, they form a cluster, and they start reporting back into sort of centralized the support center, and that's how we know it's online and up. As I mentioned before, it's not always an ideal situation. I mean, restaurants are hot to begin with, so this isn't, an idealized, and there's, things you could spill on the Nooks and things like that. So we try to get them in a safe spot, but oftentimes they are, plugged into a power strip, which a team member can unplug. So there's all sorts of various things we have to deal with and sort of engineer around. And in terms of making those truly highly available is a challenge.
And are they running like K3s, something like that?
Yeah, they're running K3s, correct.
K3s, and is each one a master? So it's a multi-node master?
Yeah, they can switch over, so yes, they can do that. They're multi-node, yeah, multi-node.
I mean, it's pretty remarkable to be able to put it into a package that is just, hey, just plug this thing in, simple instructions. You don't have to send a tech on site. And I guess that wouldn't really be feasible. I mean, you probably have 2,000 stores, 5,000, a couple thousand stores, right?
Yeah, so it's about 2,400 and counting. Most of the time, whenever any sort of thing like that we can do in the restaurant, if something goes down, we essentially just try to replace it as quickly as possible. Debugging it is hard to do, right? Like even just getting logs from them can be challenging. We're constrained bandwidth wise. So we don't want to compete with, we want to compete with the restaurant as little as possible. for their internet bandwidth. So even getting an image down there can be a problem, but logs are sort of out of the question. We can send metrics, right? But logs aren't. So debugging it is sort of a tricky proposition to begin with. And so we just replace it.
Oh, gotcha. Okay. So one person said their 15-year-old daughter works at Chick-fil-A, and they're going to Eric's going to teach his daughter a couple of CTL commands so she can be some local IT support for you. I'm sure you appreciate that when people launch in and do that.
Yeah, no, as much IT support as we possibly can. Honestly.
So this goes into, I mean, a couple people have questions about this. So Lancey says, how are updates handled at the store? And Tiramosus has a very similar question. He says, does Argo CD work on pull mechanism? Does it periodically check the GitHub server for identifying changes in the repo? And then as a follow-up question, I would have, do you have any issues with when you release an update that triggering such a flood of requests that you actually sort of DDoS your repo provider in a way? But maybe you could walk us through that process a little bit.
Yeah, so rollouts to the store are managed by a internal tool we call Fleet. Fleet handles actually a rolling update of the store. So they'll go to a pilot set of stores first, and we'll make sure things look well and that it's going smoothly. And then we'll go to a larger percentage and a larger percentage and a larger percentage. So it takes actually a long time to roll out an update to all of the stores. And so it's very slow and methodical. And if anything happens, we'll stop that rollout from occurring. And we can leave sort of the entire Uber cluster, if you will, and kind of, half updated, half not until we get it resolved. But yeah, it needs to be done very slowly. And there is a proprietary tool on top of that managing it.
Okay, so with Fleet, integrating with Argo CD, I mean, does you basically have these standalone Argo CD instances, and they have their applications that are configured, but there's some kind of mechanism with Fleet as a go-between. So when I change my repo, it doesn't just change everything. Does that go through, like, does it iterate in Git and say, these are now the available targets, or it's not really aware of the targets and it's just whoever is checking in for updates? Like, does it, or how does it work that way?
Yeah, so Fleet has essentially a set of known restaurants it wants to update. The sort of the pilot ones, like I mentioned, the target ones, it will push those to the cluster. And so Fleet is acting largely, it's sort of taking over the entire GitOps process in that case. And Fleet really runs it end to end in terms of what's going to which restaurants and clusters. And then, checking to make sure that they're okay. So like I said, we get comprehensive metrics data about the entire state of the cluster. Inevitably, at least someone in the cluster is down at any given time. But that being said, Fleet is really managing the end-to-end process.
Oh, gotcha. Okay, so this might go to Greg's question, who is asking what the process is for a developer to deploy a new application onto these clusters. And I imagine there's a fair amount of gating. Like, anytime I'm operating an edge cluster, the thing that I always notice almost immediately is how quickly I run out of memory. And so what does that process look like, both in terms of what kind of testing you do, and then what does it look like in terms of they just commit it to a repo, and once the pull request is approved, then it rolls out? Like, how does that work?
Yeah, so there's an entire team that you sort of have to interface with to get anything deployed actually to an edge cluster. And we have a series of labs that you start with. And so you'll be granted access to a lab, and you'll be set up with that. The lab is as close to a restaurant setup as we can get it. And so it's 3 Intel notebooks, exactly like what you had before. You can't pull logs and things like that easily. You can there because it's sort of required, but we kind of make it challenging to some extent. So you have a taste of what the actual prod environment will look like. And so that's the first setup. Now, largely people are taking, well, say largely, we're leaning in the direction that folks are trying to take cloud service, things that have been designed for the cloud, and run them at the restaurant. So the first step is to like rip out all AWS related things. And you need to get your container sizes down to something reasonable. Oftentimes, that hasn't been a real driving factor. But we can't push, say, a 500 megabyte container down to the restaurant very easily. So oftentimes it will require a switch to go. Unfortunately, for better or worse, we're trying to get better about that.
A switch, like what do you mean?
You'll need to rewrite your service from Java. Typically it's Java, they're coming from Java to go. And
just because of how much memory they normally consume. Maybe if they're coming from Java, typically they require more memory.
Yeah, particularly if it's a cloud-based service. That hasn't been largely a constraining factor, and now suddenly it is. We're getting better about that. So we certainly aren't interested in rewriting every single Java process. So we spent some time getting better about that. But largely the services that are running there now are Go, particularly the services that are sort of doing the overhead and maintenance of the cluster are all Go based. And so yeah, that's really one of our first entries actually into Go there at Chick-fil-A was that. But yeah, no. So you got to really start streaming it down and rip out a lot of dependencies that you don't need. And then managing state is tricky there, particularly if you can lose the entire cluster at any second if someone unplugs it. So you really need to have the ability to just sort of recover and rehydrate yourself from either a cloud service if you have to, or just start fresh and come back up.
Yeah, and I assume like these services aren't like, you don't have anything that on the container startup it downloads some sort of war file or something. Like these are dry containers, right? I mean,
and they're not, they don't need to be cloud scale, right? Like they're the number of people that it needs to service is very small, particularly compared to cloud scale traffic. So a lot of the things that you're guarding against in a cloud environment, you don't need to do.
Well, and then sort of, actually, this kind of goes dovetails with the question I have. So I know that with K3s, you can update your Kubernetes node sizes using like upgrade system controller. What about underlying OS upgrades? And also, Thomas asks this more just, do you use Argo to build infrastructure itself? And I assume that that's kind of what he's getting at. But maybe a dovetail off that question would be, does your cloud services team use a similar approach? Did they learn from your team, or did you learn from their team? How did that happen?
But it's definitely both. So we started actually completely with we had a different platform that was based on different technology. When we started, we knew we ultimately wanted to unify these two things so that we weren't deploying to two different kinds of compute platforms. So we started with Edge. And so, yeah, the cloud services actually learned a lot from the Edge. Now, things are dramatically easier to some extent in the cloud. We can update things immediately. We're not bandwidth constrained. But we have a scale that the restaurants don't have, at least each individual cluster doesn't have. But yeah, no, we learned a lot. And in fact, we started, our original GitOps operator was a version of Fleet. So you actually still see in some of our repos, particularly manifests that haven't been touched for a while, they'll still have sort of a heritage Fleet tag to them. So you can see that legacy still in the cloud services today. But as we sort of push forward on the cloud side, we started feeding things back in to the Edge stack. So in particular, a lot of the monitoring that we pushed forward, we ended up sort of handing that back over to the restaurant team. And then things like Argo CD that we found and really preferred to our in-house things, we also fed those back in. So now largely CAP can create both sort of kinds of clusters, and it's kind of used widely. But for a while there was, and while we designed CAP the way we did, was to be composable so that largely the Edge team could change out the components they need to.
And you don't use something like, I don't know, Tinkerbell to provision these Intel Nuke nodes? I mean, you probably have like a thumb drive you just plug in, and then for your cloud stuff, are you bootstrapping the clusters using Argo CD, or are you just running like Terraform and then that installs Argo CD, and from there you're on your way?
Yeah, it's actually mostly CloudFormation. So we just use EKS Cuddle, which is ginning CloudFormation behind the scenes. We try to be as we don't really have like a multi-cloud strategy. So some of those things like Terraform, they still make sense, but we tend to rely on the AWS native services like CloudFormation pretty heavily. So EKS Cuddle made a lot of sense for spinning up the cloud clusters. So that's what we use.
Yeah. Have you any thoughts about Crossplane at this point? I mean, I've been using EKS control successfully and enjoying it, but the first time I did something with Crossplane and just committed it to the repo and like Argo CD spun it up, my face sort of melted a little bit. And so I wonder if that has triggered anything in your minds.
It's tough right now because we have a very strong alliance, I think, on the AWS native services. So I mentioned we use DynamoD pretty heavily. It would be tough to rip all that out. Now we do on the edge, and there's a distinct path in the code that can sort of avoid, I guess, AWS dependencies. But even then, we largely so we've solved all of these problems, and some of them we sort of like half solved, but really we're looking for partners to solve these in the next iteration of particularly the Edge platform. So you mentioned like updating and keeping the operating system patched. Yes, we absolutely have to do that, and we do it today. We would like to get out of that business, I would say, because it is a monumental task, and there are folks that are far better at it than we are. Although I think our first pass at it, it was very important for us to do it ourselves because we learned so much, and now we know the right questions to answer are asked, and so we can assess sort of vendors and folks that can do this much better because we've done a lot of it and we've run into a lot of these problems. But ultimately, we would like this to be a much more managed service than it is today.
Yeah, so there's a question. Can we add an extra cluster for deployment from Argo CD CLI? I think he's asking if Argo CD can be used to manage deployment to multiple clusters. The answer is yes, and you can do it from the Argo CLI. So let me know if I got that question wrong. For the infrastructure part, what OS are you using on your edge nodes? You're not using the K3 OS, are you? I mean, that's so new. I didn't think it would be adopted at this point.
No, we're not. And although we have, it is on our radar, and we are looking at it, particularly for the next version. So, and actually, the Nukes have been out long enough that they're actually about to start a refresh cycle. So they were supposed to be there for 3 years, and they're about to start a refresh cycle now. It's a flavor of Debian, I think I can say.
Fair enough. Okay, fair enough. Yeah, when those come up for recycling, send me a note about where those are going to get into the recycle stream, and maybe I can get on that surplus train for a bunch of Intel Nukes.
That's true. I didn't think about that. We had a large recycling problem.
I mean, you've got 2,500 stores times 3 nodes, so I mean, we're looking at quite a few machines.
And there, if you guys want to see some pictures of this, I mentioned our medium.com blog post. There is a blog post there now from Alex. I mentioned Alex Train earlier. He wrote that original blog post. And there's some pictures of what the Nukes look like deployed into the restaurant, and sort of how they're networked together and those kinds of things.
All right, I just threw it in the chat. I think I found the right one. I'm looking to
That's
see if
it.
it does
Yeah.
have a picture of the edge. Oh, I don't see any pictures of the nodes themselves.
Oh, they don't. I thought they had them in there.
Maybe I have the wrong one. I do see a Chick-fil-A store, but I can't see the Kubernetes cluster from here.
Let me see. I thought. Oh, wow. I thought we had the pictures in there.
Bare metal K8 is. Oh, yeah, this is it. Okay, yeah.
Oh yeah, no, this
Eric
is the
posted it.
this is a later one. Yeah.
Eric got it. Oh yeah. Oh yeah, these are just the straight up 8 gigs of RAM, super simple Intel Nook. I have one of these laying around the office. That's pretty rad. Okay, cool.
Yeah.
And I assume like the 3 nodes is meant for failover. So you're not running applications where you need. Was it for failover, or is it I have enough applications that it fills up 1.5 nodes or 3 nodes even?
Yeah, it's a little bit of both. We thought, I mean, 3 is sort of kind of like the minimum that felt like an actual cluster and product to deploy down. But more than that seemed overkill. So it is certainly both reasons that we have 3. Most applications will fit on a single one though. So it's mostly the failover case.
Gotcha. Okay. Before I ask another question, just a reminder that the next meetup, the next Argo focused meetup is going to be, I think, in 2 weeks. Oh gosh, I should have had it on my mind before I opened my mouth. I'm sorry. Let's see. The next one is with Ricardo Roca from CERN, and it is April 6th at 5 p.m. And I'll throw a link to that in the chat. This one is going to be the link for Atlanta, but if you're joining from a different location, you can use you can just Google it and you'll find it. But that's Ricardo Roca is a great guy. He's actually running the program committee for KubeCon Europe right now, so I'm glad he was able to squeeze us in with so much going on. Yeah, running edge clusters, Christopher. I have a setup back here where I've got a couple of atomic pies. I've got a 5-node atomic pi cluster. Those are 2 gigs of RAM each. And so the bane of my existence, because for scale, it's like it's only there's no vertical scale in that stack at all. Yeah. So it's all about the horizontal scaling. So anytime I deploy something and it's like, oh, it has a daemon set, I just curse. It's like terrible because it's like, oh man, I can't, like with all the daemon sets, like I was using Longhorn from K3 from Rancher plus Prometheus. And by the time all the daemon sets got deployed, I was basically out of memory to deploy anything else. Yeah. So I had to give up on using Longhorn. Wasn't fast enough to do that. And then Prometheus, I really scaled back what was going on there because it was consuming so many resources. I've upgraded. I've got 3 HP Elite Desk G3 hundreds back here. So now I've got 16 gigs of RAM in each node. It uses substantially more energy, but my services run much faster.
Yeah, the amount of memory Prometheus uses is astounding sometimes.
Yeah, and you said you aren't doing logging. Are there other things that kind of surprised you? I mean, you've got people rewriting services from Java to Go just to save on memory, which is obviously time consuming, but also pretty cool because then you're modernizing. Are there any other surprises that hit you from running these clusters at the edge?
Yeah, I mean, there are. I mean, the biggest, I think, disconnect from moving is that you don't have access to AWS control plane or whatever it is you're using, and there is particularly for us, we just rely so heavily on those to push things forward that it can be very jarring to switch over. And then the other big thing, which is always a huge surprise for everyone, and I'm sure will be a surprise there, is there's no persistent volume claims.
Yes, that was going to be my next thought because I was like, I didn't notice in there that they had anything about persistent volume claims at all. So you have no stateful services on the edge at all.
That's right. Yeah. No. And so that is a big mind switch for a lot of folks. And it certainly is still for me too, particularly now that I've been working in the cloud environment for a while. But yeah, no persistent volume planes. We would like to solve that in the next version, but right now, no PVCs.
Yeah, I think there's a couple of tools out there. Longhorn, I don't think is geared for it, but there's another one that basically provides storage from each node, and then it kind of replicates it across the nodes to provide some
Yeah,
PVCs.
Yeah, we've been talking to a few folks about the best way to do it. It's not an easy problem to solve.
Yeah, I'm trying to remember. Yeah, and I mean, just from my experience, I've tried all of these things on my local cluster, and it's been a pain. And until I upgraded to the Elite desk, now Longhorn runs fine with the memory I have. But Lancy says there's a blog. The blog actually has a question. It says, "Why use Nukes? Why not use Cloud for the Edge?" And I guess I don't know if Cloud for the Edge is referencing the AWS Fields box that they'll sell you, and I'd imagine it's cost. I think those are much more expensive than 3 Nukes.
Yeah. So one Outpost, which is if that's what we're discussing from the AWS side, didn't exist when we first started, so that was a problem. So each one of them kind of has a edge compute that's of that same footprint. So AWS has Outpost. I forget what the Azure name is, and I forget what the GCP name is, but
like
they all have something
that's
they all have something around those things. There are some tricky dependencies on there. And so a lot of them are geared for like manufacturing use cases where you have like a dedicated closet for these sorts of things. We don't. These are going into back rooms. We don't have sort of the dedicated ports and switches that you need to run some of those things. They're getting better. And then a lot of them, at least initially, had a kind of, they always need to be tethered to the AWS control plane. And we've got to be able to run offline. And so there were some things that just didn't work there. Cost is a gigantic major factor. Although I think if we could solve the other problems, we could solve that one as well. They're getting better. So initially it was, kind of like a full rack you had to find space for. That's a non-starter. We don't have that space. They're getting smaller and smaller footprints that would actually fit. So you think about it, to replace it, we've got to get rid of something in the restaurant, essentially. There is a PC back there now that we could replace. But it's got to be that kind of form factor. So there is sort of some problems with our particular use case in running. Now those things work perfect, and that would be the solution if we were talking about manufacturer, even retail sized stores. Those are exactly the right solution in my opinion. But in our form factors, it can be challenging.
I mean, it's pretty cool. Like, we're talking about this as edge, but in a way it's almost air gapped because you don't necessarily rely on any external services. So if the internet connection were to go down, the in-store stuff that's handled by the cluster is still going to operate.
Yeah, it's still, if we do not have internet connection, it still has to run. That is something. Now, one option for figuring that out is getting better and better with your connection, so that you essentially, that is just a very unusual case. And if it does happen again, you could fall back to the, hey, we're just going to send someone to replace it, right, within a certain amount of time period. But right now, any sort of break, say if you lost it during launch, well, now you're talking about a pretty expensive downtime, particularly for that location and operator.
So I think we'll just close out with there was one other question, but I don't know that it was really something for you because it seemed to be about, well, I'll read it, but and we'll close out. They said, I don't have a question, but just wanted to say I totally commiserate with the awkwardness of trial and error approach to configuring workflows in YAML. It would be so wonderful if there was an autocomplete or hints in the same way that my IDE gives me hints as I'm writing source code. And I wasn't sure if, because they were mentioning workflows, and I was like, Argo workflows, like, or maybe they were just saying like the applications, the app of apps, that kind of stuff.
Yeah, so I mean, sort of what we're getting at is someone who's personally spent a lot of time writing like sort of the base manifest. It requires actually in-depth knowledge of Kubernetes. That's a given, but you actually have to go to the teams and understand their use cases and how they've written their application too. So it requires this kind of like expert knowledge in two fields. It's very challenging in my opinion, and writing those repos is difficult. But when you're writing Python or Go or Java, the IDEs will help tremendously and give you hints about what's valid there or not valid. There's just a lot of benefit that IDEs have come with, particularly these days. But with YAML, you're kind of like, particularly Kubernetes YAML. Now there's some things in that space that are getting better. But I think there's just an opportunity there. It's certainly not, like I said, it's certainly not something we want to solve personally, but we would love if if we could partner with someone from the community, or if there was some open source projects that we can contribute to help in this regard, because it does feel like trial and error. Or maybe I've just missed something in the space. That is also a potential. I feel like
you want an IDE that's sort of aware of the cluster resources, cluster addresses, as well as like what customizations are being referenced, or maybe what Helm charts are being referenced, what values are potentially available. It's a really interesting problem to solve. So we'll leave that for the community and put it out there that Christopher Lane is buying if you've got it. So send it on over his way and he can give a review of it. With that, I think we'll close out. I mean, great job, Christopher, and really appreciate you hanging out and doing the Q&A with us. For those that are looking for more Argo content, obviously the meetup for Argo is coming up on April 6th. And that's Ricardo Roca with CERN. There is a GitOps certification that CodeFresh offers that's free. It's all about using Argo CD. Level 1 is currently available. Level 2 is expected to drop in the next few months. So you can do that. Just search for GitOps certification CodeFresh, and I'll post a link to that. And then don't forget to register for GitOpsCon as part of your KubeCon registration. And did I cover everything? Oh, also, if you're using Argo and you want to use Argo at scale, or you want to know what a fully integrated experience of having everything unified into a single platform would look like, you've got CodeFresh, codefresh.io. And we actually have the CodeFresh software delivery platform, which is all built on Argo CD, Argo workflows, Argo events, and brings it all into a single UI and gives you a control plane for managing many instances of Argo. So with that, Christopher, last word, anything you want to add?
No, just thank you guys. And I appreciate the time and the questions. And also offline, if folks want to reach out, I'm on LinkedIn, obviously. And so happy to answer any follow-up questions. But thank you so much for the invite and the time and the questions. I appreciate it.
Okay, well, there you have it. Take a minute, take a break, go get a beer. It's beer o'clock at 6 p.m. Have a nice night, everybody.
Thanks, guys.